Okay, so this is your assignment on vectors. It goes in the same category of your marks as your lab reports and things like that. Okay, so it'll count in there along with the map assignment, which reminders due on Thursday. Okay, so these start out ridiculously easy, and then they kind of progress. Okay, so tips and hints here. Tip for question number 1. My tip is don't overthink it. Okay, you have in question number 1 2 displacement vectors, D1 and D2, and they both point 35 degrees north of west. That is, they go the same direction. Okay, one has a magnitude of 4.60 kilometers. The other has a magnitude of 3.20 kilometers. What are the magnitude and directions of their resultant vector? Okay, you have 2 vectors that go the same direction, and I want their resultant. All right, draw a diagram of it, and don't overthink it. All right, there is one thing you do need to be mindful of, though, and that is, that's for some reason my marker is weird. Okay, is significant digits. Okay, there is a little significant digit trick here. So here's what I want to remind you of. When you add numbers, remember that significant digits are trying to maintain accuracy. So these 2 numbers are measured to the same accuracy. Would you agree? Since they share a direction, this is not really part of that addition operation, is it? Not really. Okay, so it is possible for an answer to have a certain number of significant digits in the magnitude and a different number of significant digits in the direction if they are not used to calculate each other. Okay? Anyone follow me there? Remember, significant digits, you only worry about it if you use it to calculate something. Well, you're not really using that direction to calculate the magnitude, if you catch my drift. Okay? All right. Number 2. 2 heavy ropes are attached to a box. Okay, a heavy box pulling it along the floor. One rope applies a force of 475 newtons in a direction due west. The other applies it of 315 newtons due south. Okay, force is a vector quantity. So here's the thing I'm going to tell you. People visualize this one, which we talked about is really important. Okay, they visualize this and they do this. And they draw a box and they say, all right, it's being pulled this way and this way. Okay, and then they do something weird with those vectors. And it's wrong. Because right now, those vectors are drawn tail to tail. Would you agree? Is that how we draw them? All right. Here's what I want you to do when you visualize this. You can look at that, but then forget about that. And think about which way the box will go. If I pull it this way and then this way, even though they're happening at the same time, it's like I do one and then the other, which way will it go? Think about that when you're drawing the vector diagram for that question. Okay? The vector diagram is what's important. You know, the tail to head thing that I've beaten you over the head with for 2.5 weeks. Okay? All right, number 3. Boat travels due east, 5.74 kilometers, then 25 degrees, and then travels 25 degrees south of east for 6.28. Calculate the magnitude and direction of the resultant displacement. That is an exam question. Okay, you got 2 vectors there, draw them tail to head, don't overthink it. Okay, that's easier than the one you did on the quiz today. Okay. All right, number 4. Okay, displacement vector is 145 meters long and points at an angle of 28 degrees. I'm going to underline this. Above the negative side of the x-axis. What are its vector components? Okay, so all this question wants you to do is find x and y for that vector. Okay? Remembering that in an xy scatter plot, this is the negative x-axis, this is the positive x-axis. So when you draw that diagram, draw it the right way, and then here's the key. I want the actual vectors. Don't give me compass directions on this question, because you are not given any compass directions in this question. Okay? You are given where this is on an XY scatter plot. Okay? Your vectors are simpler than that. Okay, and number 5 is also a vector component question. Find x and find y, except this time you are given compass directions. So it would be totally appropriate for you to give me compass directions on x and y. Okay, so 4 and 5 are very similar questions. Okay, number 6, okay, we have just a vector component addition question. And it is basically the same as an exam question. So you got 2 that are just like what you would get on your exam. Tail to head, do vector addition. You'll be fine with that one. Okay, now here's the other thing. It wants you to tell me the direction relative to due east. Okay, that means something of east, either north of east or south of east. It is saying you must draw your triangle so that it is telling me from east. Okay, number 7, another one. Draw the diagram. You shouldn't have any problem. It's just got 3 vectors. Okay? But one of them is due north, so it's really only 2 that you have to do any x and y stuff for. Okay? Actually, sorry, only one of them is angled. The other 2 are, one's north and one's east. So it sounds like a lot, but it's really not. Okay? Draw the diagram, do the calculations, don't overthink it. Okay, number 8. Okay, you got your pilot flying from point A to point B along 2 straight line segments. And yeah, you just got 2 vectors there. Draw the vectors tail to head. Okay, and you're good. Okay, on that one. That's pretty much the same as what we did on our quiz today. Okay, same level of difficulty, same amount of work. All right, 9 and 10 are boat questions. They're basically the same question. They just ask you slightly different things. Okay, so Diane is rowing this boat across. She's rowing it across. She's not going across. She's rowing across. That's important for when you draw the diagram. Okay, so she can row at a Herculean 8 meters per second. Okay, which is like crazy, right? And the river is flowing at 6 meters per second. Okay, what is the resultant speed of the boat? Okay, if the stream is 240 meters wide, how long will it take her to row across? Okay, and how far downstream will she be when she reaches the other side? Okay, we did a bunch like that in class. All right, now we've switched from Diane to Dave, who doesn't row as fast. Okay, he only rows at 4 meters per second. And the river, it's the same river, 6 meters per second. And it's 360 meters across. Okay, it's the same river, but it's a different spot in the river where it's wider. Okay, so what we're looking for here is, in what direction relative to the shore does Dave's boat go? Remember that Dave is rowing across. He's not going across. He's rowing across, just like Diane did. Okay? How long does it take him to get across the river? How far downstream does he end up when he gets to the other side? And D, simple mathematical question, tricky context. How long would it take Dave to cross the river if there were no current? There's still water. Okay? He doesn't get to walk or anything like that, but there's no current. Somebody puts a dam there and it doesn't flow anymore. Okay? How long does it take him to get across? Okay? Questions on any of those? If there are questions while you're working, that's fine. Okay, get going on it. You're going to get time tomorrow as well. Then the rest of it will be homework. I'll come up with a due date here shortly, and probably start looking at when our unit exam might end up being as well. Okay, because we'll be getting closer to that. Okay, get to work there, guys. Okay, so due date for this guy's March 5th. Okay, it's a week from today.